today. So what have we done so far? Let's do a quick little recap. So far in this 4 lessons we've done something called the distance formula. We've done something called the midpoint formula. We've done something called the gradient formula. We've also done the fundamental or the standard form of a straight line, where m is the gradient and c is the y-intercept. And then we also did something called the angle of inclination, where we said the formula that we used was tan of theta equals m. So we've done quite a lot of stuff, and today's lesson is going to focus on a couple of extra things, but we're always going to come back to using these tools. So you want to get more and more comfortable using the tools in your toolkit. As we start to talk, we're going to talk a little bit more about parallel lines. We're going to talk a bit about perpendicular lines, or lines that are at 90 degrees to each other. And we're also going to talk a little bit about different types of triangles and different types of quadrilaterals. Now, quadrilaterals have 4 sides and triangles have 3 sides. So that's the kind of blue stuff is where what we've done, and then the red stuff is where we're going. Can you give me a thumbs up if you feel like you sort of know the blue stuff? And give me a thumbs down. Maybe you're new and you've never done any of this stuff, or maybe you just don't feel confident yet. Thumbs down if you don't feel confident with the blue stuff. Thumbs up if you feel like you have some background in that and you feel like, yeah, I may not be perfect, but I could take a shot at this. Okay, awesome. Okay, well, let's go on to talking about gradient a little bit here. And I want you to use the gradient formula for these particular lines. So I want you to find me the gradient of the line DC, and I also want you to find me the gradient of the line AB. So we are kind of going back to the previous lessons in this. So for our new students, don't worry. The gradient formula that we discussed was this formula where, for example, the point A is that point and the point B is that point. So we have to use those 2 points in our calculation, like -5, 2, and the point here was 1, -1. Okay, find me the gradient of those 2 lines. Go ahead. See what you get and see if you notice anything about them. Okay, so when you're ready, maybe you can put your answer in the chat and just let me know what you what you get, and if you notice anything interesting about them. Let's have a look at the green ones. So what would the green ones be? Oh, no, my pen was being a bit funny. So go. I often think it's a good idea to go 3 minus minus 3 like that. And then we go -1 minus -4. And then we get yeah, let's go to Sigma. Can we unmute Sigma? I see the hand is up there. Hi, Sigma, can you hear me? I feel like
so we use tan theta is equal to m to find the angle of inclination.
you do,
Yes.
but we're not doing that right now. So right now, all we are doing is we are finding the gradient of these lines. Okay, I tell you what, there's a bit of a bad line, so I think we're going to mute that for now. We'll come back to it maybe when the line is a bit better. But I want to ask, what do we notice? I think we mute there. There we go. What do we notice about the relationship between these two lines? And what I want to say to you is that these lines are negative reciprocals of each other. So the way I would say it is that the gradient of DC is 2/1. Can we maybe mute there, just so that we don't get too much interference? So what I want to point out to you is that when lines are perpendicular, so the line DC, yes, let me just get this. The line DC, if you look at the drawing, it shows you is perpendicular to the line AB. And when you have perpendicular lines, what you notice is that there's a relationship between the two gradients. They're going to be negative reciprocals of each other. So once you have the one gradient, you can get the other by simply just flipping it over and then changing the sign. So that's the first thing I wanted to point out. Okay, so when lines are perpendicular, there's something that happens. Now, I want you to find me the gradient of GH now. So the next question is to find me the gradient of GH and also find me the gradient of EF. Okay, go ahead and do that, and I'll give you a bit more time, and we'll see what happens here. Okay. Just want to check, Label, can you see me okay?
Yes, I can see you, Mr. Ayers.
Fantastic. Okay, so Zander, we're not finding the angle at this stage. All we're doing is we're finding the gradients of like the pink lines. Let's call that GH. And we're also finding the gradient of EF, which is this one over here. So for GH, what's my gradient going to be? So it's going to be, let's have a look. So 4 minus 0 and 4 minus 2. So notice how I'm taking these 2 points and I'm getting 4/2, which is 2/1 or 2. So the gradient of GH is 2. Now, what's my gradient of EF going to be? That's this green one over here. And then we're going to sit back and make some conclusions. Aha, I see that. So for EF, we've got 0 minus 2 on the top. So I'm just taking these two. And then 5 minus 1. So I get -2/4 or -1/2. So what I want to point out to you is this drawing is showing you something rather interesting. I want to ask the students, what is the relationship? So we've done some working out. We found the gradient of these different types of lines. And I want to ask you, what is the relationship between the pink and yellow lines? So if someone can come online, maybe tell me, what do you observe the relationship between the pink and yellow lines are? So that would be, the pink one is GH, and the yellow one is CD. Who feels like they can spot the relationship? Aha, Lutando and Lasedi. Yes, these are parallel lines. So you can see that they're equidistant apart. And the other reason we know they're parallel is look at their gradients. When lines are parallel, they will have the same gradient. And you can see that because here is CD, the gradient is 2, and GH, the gradient is 2. So one of the first ideas I want you to learn tonight is that when lines are parallel, they will have the same gradient, or the other way around works too. If you have two lines that have the same gradient, they will be parallel to each other. So that's an important new idea. Now, I also want to explore for a second the relationship between, let's say that what is the relationship between the green line, so let's say the line EF, so the line EF, which is the green one, and the yellow one. So the yellow one was CD. What is the relationship between EF and CD? So isn't the EF positive? It is positive. EF, no. So the EF is negative. No. If you look to look at the green line, it's sloping down to the right. So it is meant to be negative. Okay, so EF, even though it's over here, the gradient was -1/2. And CD, the gradient was 2. And what you notice is that these two lines are perpendicular. And when lines are perpendicular, they don't have the same gradient. What they have is they have negative reciprocals. So the way we would say it is that, for example, here, if you know the one gradient is 2, to get the line that is perpendicular to that, you just flip it over. So you get 1/2, and you change the sign. So if it was a positive, it becomes a negative. Okay, so what we have done so far is I have showed you visually and numerically how to identify parallel and perpendicular lines. But I think we need a bit more practice. So what I'm going to do is make up some questions for you now. So my made-up question number 1. Bokang, how do you tell if the line is sloping up or down? The green one is going down in the direction because the y-axis goes down in that direction, whereas the y-axis goes up in that direction. So you can visually see the green going down. Okay, if I tell you that there is a line, I'm making it up now. This line will be, let's call it PQ. And I tell you that the gradient of PQ is 3. I then say to you that there's another line, and this line is perpendicular to PQ. What will the gradient of this other line be? So if it used to be 3, what do we know about perpendicular lines and their relationship? So 3/1 will just become 1/3, and we just change the sign to a negative. Another thing about perpendicular lines is sometimes they say lines are perpendicular if when you multiply their gradients, you get -1. So let's just check. If I multiply 3 by a -1/3, I get -1. Okay, so you guys have indeed done this right. And so the gradient of this other line will be a third. Okay, now, let's say I have another line, and I'll call this line xy. But this line is parallel to the original, it's parallel to the original one, PQ. What is the gradient going to be of this other line, xy? Yeah. Easy peasy, no problem. So if lines are perpendicular, they're negative reciprocals in terms of their gradients. If lines are parallel, then the gradients are equal. And if you see lines that are equal, you know they're parallel. If you see lines where their gradients are negative reciprocals, you know they're perpendicular. Now that sounds very wordy, so I don't want you to worry about my words. I want you to see this in action. So let us find, okay, here we go. I'm going to give you this set of points, and I want you to find the gradient between these different points. So you are going to work out the M of AB, the M of AD, the M of AF, the M of AC, the M of AE, and the M of BC. And I want you to find me which lines are parallel to each other. So which lines are parallel and which lines are perpendicular to each other. Off you go. And students who are feeling a bit overwhelmed or confused, I'd love you to ask some questions now as we go about trying to solve this. The formula for gradient that we're going to use to find the gradient is this. So we covered that in previous lessons, and so especially if you missed it, I would recommend going back. But for now, let's do it. Over to you, students. Let's rock and roll. Does anybody have a question while students are working diligently on this? Okay, Kutwano. So we're going to first find all our gradients. So you'll see that there's a whole bunch of different points, right? And first of all, you find the gradients. Then you look at the relationship between the gradients. If the gradients are the same, we know they're parallel. If the gradients are negative reciprocals, or if we see, an easy way of saying it is like, if you flip it over and you change the sign, if that's the relationship, then they're perpendicular. So a reciprocal, Annie, is like if you have 2 over 3, the reciprocal of that would be 3 over 2. You just flip it over. The negative reciprocal of 2 over 3 is just going to be negative 3 over 2. So you just change it from positive to negative. So I want to see those answers coming in from the chat. So I think that first one, and then what do we have? -7, -6 to -13, and then 2. So that's going to be 13, I think, for that one, which is -1 for that one. Take the time you need to just find the different gradients. The first one should be -1. So it's AD. So maybe we can do this together. We can use each other's work. We'll give you, yeah, let's see what else we get. AF 7 minus 6 is going to be 1, and then 1 minus 11 is going to be 12. Let's make sure. So 7 minus 6 is 1, and then 1 minus 11 is plus 7. So that's going to be 1 over 12 is what I get. And then what do we get for the other ones? 5 minus 6. So that's minus 1. Three, 14. Okay, just 2 more to go. And I want you to start thinking which ones are in what relationships here. That's AE. I agree with you with AE, and then let's just get BC. 5 minus 7. So that's 5, that's 12. And then 3 minus 2 is 1. Okay, now let us look at all our gradients and find ones that are parallel. I think the first one that I spot that's parallel is AB and AE. So AB is parallel to AE because they both have gradients of -1. Are there any other ones that are parallel? Can anybody spot anybody else that's parallel? Nope, I can't see anything else that's parallel. Are there any ones that are perpendicular? Who would like to tell me? I want to hear a student voice. Who can share with me what they think are, who'd like to put their hand up? You can do it. I see lots of, there we go. Let's go to Bukang. Hey, Bukang.
Oh, good evening, sir.
How's it going?
I'm good. How are you?
I'm very good. Tell me, what is perpendicular?
Then AF and BC.
So AF, so this one over here, and BC. Now, I'm looking, did I make a mistake here? Because I see they switched, but what's worrying me is that they don't, can you see they're both positives?
Yeah.
So let's just quickly have a quick check that we didn't make a silly mistake, because I agree with you, but that's, it looks like those ones.
If I'm not mistaken, AF is supposed to be negative.
It's meant to be, which one?
AF negative because BC I got 12. Like I got a positive number.
So you go for AF, you got -1/12. Let me just check.
Yes,
So
sir.
7 minus 6 is 1, and then 1 minus 11, 1 minus -11. Now I get 12. I get 1/12. Let's have a quick look at the chat and see if anyone gets anything different, but I still get 1/12. And then BC, 5 minus -7 is 3 minus 2. So maybe there's been a typo, but at the moment, I don't see, let's have a look at AF and BC. Okay, guys, I think there might be a typo because if I go back to the chat, I don't see anyone getting -1/12. Let's have a quick look here. everyone gets 1/12. So I think there might have been a typo in the actual thing. In order for these two to be perpendicular, the one would have to be negative and the other would have to be positive. So I actually, at the moment, I don't see any lines that are perpendicular, even though I suspect in this question, it may have been that we were trying to get those two. Okay. So at B, it's -7, -7. When stretching time, Tommy, we're going soon. So at B, it's -7, -7. So B what? BC. So at BC, it's 5 minus -7. So 5 minus -7 is 5 plus 7, which gets me 12. And then 3 minus 2 is 1. So I'm pretty confident of that one. Okay, so it is time for a stretch. So all that we did in the first part of the lesson is that we said, look, for parallel lines, the gradients are the same. For perpendicular lines, we need negative reciprocals. But the important bit is that in this one here, these are just reciprocals. There's no, we need to have an opposite side. And so actually in this question, there are no perpendicular lines. Okay, we'll come back to this after the break. Let us all stand up. And it is time for me to remember how to unshare my screen. So stop your screen sharing, stop share. And I want everyone to stand up because I'm even dressed in my gym clothes already. So I'm ready to go to gym afterwards, but I'll do a bit of gym with you first. And let's start by just swinging on our shoulders. Just loosen up.
Please put on your cameras, guys. Let's see your lovely faces.
Okay. And then let's twist our bodies a little bit, swinging from side to side. Maybe just as you are loosening up. Oh, that feels good. I'm not going to lie. When you're sitting the whole time, it's so nice to just be free. Okay. Then let us stretch. So we'll stretch like this. And then let's stretch like this. Okay. All right, then let's do a high heart rate. We're going to stick with the air skipping or the virtual skipping, and we're going to do 30, and we're going to start in 3, 2, 1. Let's go. 1, 2, 5, 6, 7, 8, 9, 10. 17, 18, 19, 20, 21, 22, 27, 28, 29, 30. And then you can sit down and hopefully your body appreciates that little bit of a break. And let's have a little bit of a puzzle. So here I would like to know, what is a clock times a soccer ball minus a fan or whatever that is there? Who thinks they know the answer to this? Ndumiso, or how did you, let's see. Well, I agree with Ndumiso that this one over here must be 6. So I guess I can write that in like that. So then the clocks must be 3. You're quite right. Now we're getting a little bit sneaky with this last bit here. What's this going to be? Ayanda, I see that enthusiasm. So the clocks. Oh, I see Mayton has said that 3 times 3 is 9, minus 3 is 6. Okay, so we've got that. But now we've got BODMAS. So what's the final answer going to be? Pop your answer in the chat. It's your time to shine. So BODMAS says you have to do this one first. And so we get 18 minus 3. And so your final answer, Felisois, I agree with you, is 15. And Hearties, I agree with you. All right, everyone. Very nicely done. you passed the brain test, so well done to you. And I hope that you are feeling a bit, yeah, like you took some time to stand up, stretch, and that your body is ready for the second half of the lesson.
Nicely done, guys.
Nicely done. Now, what I want to do here is I want to ask you to use some of these ideas that we were doing now, but we're going to combine them with a straight line idea. So I will do a first one, and then you guys are going to do a second one by mimicking it. So the question says, determine the equation of the line passing through the point. And in this case, the point is 2/3 1 and is parallel to this line over here. Now, we know that all straight lines can be written in the form y equals mx plus c. I want to ask someone in the class to help me. I have a feeling that because I know that the line I am looking for, the equation of the line I'm looking for, and the line that I'm given, because they're parallel, I might be able to use some information. Who can tell me how I can use this parallel thing to my advantage? I need a student to help me. So my goal is to find the equation of the straight line that it mentions. I know it's going to be in this format, but I have to use the information that I was given, which is this. Okay, Lesedi has said because the lines are parallel, their gradients are equal. And so the gradient we know in this line is 4. So the gradient in the line I'm looking to find is going to be 4x. And so I can put it in here. The other piece of information that I'm given is this point. Now, because it's written like a mixed number, I'm going to convert it. I'm going to convert it to an improper fraction. So 2 2/3, I go 2 times 3 is 6, plus 2 is 8. And so this point is the point 8/3 1. It's so much easier to write your points in improper form. It's a top tip for when you're dealing with straight lines. Improper is your friend. Then I need to find what C is. So I'm going to write down my A/3 1, and I'm going to sub it into this. So 1 where there's a Y, and then 8/3 where there's an X, and then 1 equals 32. So 4 times 8 is 32/3 plus C. And then I need someone with a calculator to help me and see what you get. What is 1 minus 32/3 going to be equal to? So be careful here. It's 1 minus 32/3 here. So you go 1 minus 32/3. Let's see if you guys get that for C. Okay, so I get minus 29/3. So the equation of my line is going to be 4x, and then it's going to be minus 29/3. So using the example that I just gave you, I want you now to work out the equation of the line that is relevant for B. So I want everyone to try and work out the equation of a line that is parallel to y equals minus 2x minus 16 and goes through the point 3, 2. So that's the one I'm coloring in blue. Okay, over to the students. See if you can do it. See if you can do it.
You got this, guys.
Ask yourself, what was the first thing I did? For those who are feeling generous, why don't you give some new students a tip? What's your first thing that you think we should do? I think because the lines are parallel, you know that that's the gradient is -2, and you're going to use the point 32, which is given to you. That would be my first step. But you still have to find the elusive c, so you know what the equation of the straight line that you're looking for. What do you guys think? Palesa, I got the 8/3, the previous question, by converting from a mixed number to an improper fraction. And it's just easier to work with an improper fraction. So let's see what happens. Because it's not a fraction this time, it's a bit easier. So this is a y and this is an x. So we get 2 is -2 times 3 plus c. And when this is going to be -6. When it goes to the other side, it becomes 2 plus 6 is c. And so c is 8. And so we get y is equal to -2x plus 8 is the equation of my line. Very well done, everyone. Very nicely done. Now, I'm going to take questions from any students who are unsure, but for those who are feeling comfortable, I'm going to change the question just slightly. I want you to do C for me now, where I say that find me the equation of the line where it's perpendicular to this line and it goes through this point over here. So see if you can do C if you're feeling comfortable. If you're feeling uncomfortable, I would love you to ask a question and we can have a chat about where I lost you along the way. Otherwise, I'm just going to clean my board. Who feels like, what happened to the -16? Haha. So, Lolita, what happened is, in the question, we want to find a straight line which is parallel to -2x -16, right? So let's say these are two lines and they're parallel. Actually, they probably should be facing the other way. So if I have two lines, we know the equation is -2x -16. All I do is I borrow the fact that they're parallel, therefore their gradient has to be the same. And I just use it now in my equation, but I still have to find what that c is. And so what I really do is I just ignore the -16 because it's not helpful to me. Okay. So what I do is I start by going, what is the relationship from the question? Okay, so in the previous question, they said there are two lines and they're in relationship, and the relationship is that they are parallel to each other. So you'll see there's a parallel here, parallel. So all I do is if I know that a line is parallel to another one, it's secretly telling me the gradient. They're saying, look, here's the gradient of the line you want. It's -2 in that one, and it's 4 in this one. And so use that as you try and go on your journey to find the equation. If you look at the original part of the question, determine the equation of the line passing through the points, and each question has its own new point. So let me even do C with you together, and then we can see how this works. Now, the relationship here is perpendicular. So let's just slow it down for a second. What is the gradient of the line that they give me? The line that they give me has a gradient of 3. Now, that is not the gradient of my line. Like, say, for example, here is a straight line, and we're going to say the gradient is 3. The line that I'm after is actually perpendicular to this line. So what is the gradient going to be of the line that I'm trying to find? And I think that from what we did earlier in the lesson, the perpendicular line is going to have a gradient of minus 1/3. Now, that is only part one. And often people will say, because they're perpendicular lines. Now, I know that this line that I'm looking to find, it has the format minus 1/3 x plus c, but I still need to find what that c is. And what am I going to do to find that c? I'm going to use this point over here. And so I want to challenge you to try and help me find what that c is. What would that process look like? Minus 1/3 x plus c. And I'm going to sub. I always like to write the point next to the line, so the teacher can see what's going on. And what would it look like if I sub that in? I'd get 2/3 equals minus 1/3 and minus 1 plus c. Now we still haven't, we've got to do some more maths. So we get plus 1/3 plus c. But when it comes to the other side, so let me just slow this down and make sure everyone's following, because I think I might be going a little bit quick. This is x, this is y. So that's why this 2/3 is here. And the minus 1 goes where the x should be. We already have the gradient, and a negative times a negative is a positive. Okay, let me slow completely down. So in this question, there is a line which is perpendicular to the other, and the first part is I grab the gradient. So I got the gradient, there it is. Now, once I've got the gradient from the relationship between the other line, I still need to use the point that they've given me. So what was the point that they gave me? Let's just go back for a second. Isn't the point minus 1, 2? Oh, guys, I've used the wrong point. Sorry, everyone. I have made a silly mistake there. Apologies. I should have put, I was looking quickly and I chose the wrong point. So let me reverse for a second. I think that's what lots of you were thinking about. Can you see that the point should have been that? So I understand now why you were confused. Everyone, that's what you was to shout, and then we'll get into it. So let's make sure I chose the wrong, I should have been focusing on that one there. So let's try again. Minus 1/3 is what we have as our gradient, and the point that I want to put in is minus 4. And then over here, it's going to be minus 4 is my y, and this is minus 3/4. Okay, so let's see what happens now. We're going to get a positive. So that's going to cancel. That's so 1/4. And then we get plus c. Now, what is my final c value going to be? What's my final c value going to be? So if I bring this across, I get minus 4 minus another quarter, and I should get minus 17/4. So the final equation of my line is y equals minus 1/3 x minus 17/4. Now, what I want to say is, if you got a little bit confused there, don't worry. you had every right to be confused because of the fact that instead of choosing the point that was in the question, I chose the point below, which, sometimes it does happen, but just make sure that you understand why the point is minus 3/4 minus 4. Okay. Do we have time for one more? What do you guys think? Should we try one more? I think so. I think I want you to try and do this E. I want you to do E. So for the last question of the day, you are going to try and find me the line that goes through the point 6, 2 and is perpendicular to 4y equals 3x minus 2. Now, I'm feeling like there's something a bit different about that straight line. Can somebody tell me what I'm feeling uncomfortable about? I'm feeling a little uncomfortable about E. It feels like something's different, but I can't quite put my finger on it. Who feels like they can help me? It's that 4y. Yes, Orokanisa, what do you think I should do to deal with my uncertainty here?
Hi, sir.
Hey.
What I think is that the equation of the straight line is not in standard form.
Yes, that's the problem. How do I fix it?
We're going to say 3x
Yeah.
minus 4y minus 2.
Aha. I mostly agree, but I was thinking, what about dividing both sides by 4? Wouldn't that also do this? Wouldn't that help? So if I divide
Yeah.
both sides by 4, then I would get 3 over 4x minus 2 over 4. So I see what you're doing, but I think you were moving it to the ax plus by plus c standard form. I really wanted the gradient. Would you agree with me on that, Orokanita?
Yes. Yes.
Okay.
Sir.
Perfect. Perfect. Okay. Now, that was the key thing. Now we have to go from there and say, look, we've got this line E, which is 3/4 x minus 2 over 4. Find me the equation of the line E. Or not the line E, the line mentioned in question E. And let me turn my lights on because the sun is going down. So what is my, oh, yes, I see Lolita and Mayton were on the case there. So I think the equation of my line's gradient is going to be minus 4 over 3. And the reason is I'm using the negative reciprocal because I know that they're perpendicular. So if the original line's gradient was equal to 3 over 4, we know the perpendicular line must be minus 4 over 3. That's what we've been learning about today. And then we're going to use the point 6, 2, because that's the point that's going to help us figure out what C is. So really today has really been about parallel and perpendicular lines and understanding how gradient sends us secret messages about information. Let's see. So this is X and this is Y. So this should be 2. I'll make sure I put the right point in this time. And then what work do we still need to do to get the C all by itself? Feels like this is minus 24 over 3. And I suspect 24 over 3 is actually 8. And so we get C is 10. So what is the final equation of the line that I want to find? So if we don't make 4 over 3 negative, is the answer going to be wrong? Yes, Lolita. So perpendicular lines, they have to multiply to -1 if they're going to be correct, which means that, for example, here, if you've got 3 over 4 and you multiply it by 4 over 3, you just get +1, which is not perpendicular lines. When you multiply their gradients, you need to end up with a -1. And so in this case, you have to have the negative reciprocal. You have to change. If the one's positive, the other one will be negative. If the one's negative, the other one will be positive. So that's an important idea that I want everyone to be very clear on today. I'll just give you one more example before we finish off. Like if this gradient is 7, then the one that's perpendicular has to be going the other direction. And so its gradient would just be -1/7. Okay, so that's just trying to show you why they have to be, one's a positive, one's a negative. All right, everyone. I love what I saw from you today. We really did make a good go of understanding parallel and perpendicular lines and combining it with straight lines.